Hello friends, welcome back to my channel. And in this session, in this video, we are going to talk about query encoder part or query encoder stage, which is part of RAG. So let's get started. And before we start, if you are new to this particular video or new to this particular uh, playlist, so on my channel, this channel, if you see the playlist, this is the playlist which is called as AI Generalist Approach. So if you see the playlist, AI generalist approach. So there I started with this different concepts. So starting from the base concepts of RAG, so I started with data collection strategies, converting the raw data into markdown and data cleanup and cross-source deduplication and multiple stages in the RAG. So data chunking strategies, multiple chunking strategies, semantic data chunking, and how to do embedding and this vector database step. So in this video we are going to go next and we are going to talk about the query encoder part. So let's get started. So query encoder, so it transforms the user's query into a vector for comparison with the stored embedding. So under the hood, at the ground level, the discussion or the uh, communication or the data processing happens at the binary level, and that is why we need to convert it into a vector for comparison with stored embedding. So these are also numbers only. So the query encoder, it is a bridge between a user's natural language and the machine readable vector space where data is stored. So yes, so this is important, machine readable. So machine readables are only numbers, and that is why the query encoder matters. So what are the use cases, or I mean what are the importance or internal details of the query encoder? So it should match. No, so we should match the encoder to document embedder. So what we're going to do is we have some reference, we have some document, and we are going to raise a query to the document, and we will get a response. So we are going to embed the document or the raw data with some model. So the point here is we should also encode our query with the same model. So it is must use to use the exact same embedding model for the query as we did for the initial document indexing. So reference and the query both should be having same encoder. Okay. Implement query rewriting. So sometimes the raw user queries are often short or ambiguous, so we should use an LLM to rewrite the query into more descriptive formal and detailed version. So the LLM part we will see in the demo. Okay, and this is one of the point for query encoder. Right, so we are going to see BM25 encoder, BM25 retriever also. BM25 best match 25 is it's an algorithm. It is the industry standard for non-AI keyword-based retrieval in the RAG system. Sometimes we can also see this is used in the Elasticsearch also. So we're going to see one demo. BM25 retrievers, it is must to use the exact same embedding model for the query as done for the initial document indexing. Okay, same step again. Right, so let's see a demo. So from the implementation perspective, I'm using the Olama LLM, and I'm using this model called as Nomic Embed Text, which is again a very popular model in RAG community. There are many projects, many places this particular model is used. So I'm using also the same, and I have the Olama key running. It's in my um, data folder. It's in my data folder. Okay, now uh, so this code and whatever code we are going to execute, this is also available in the GitHub repository, and the link is in the description. Okay, so from the implementation perspective, how the query encoding works. So we'll use an Olama client. Okay, we'll pass on the model and the KPI key, all the housekeeping stuff, and we will pass one query. Okay, so the query is a bit long. So what is the significance of different colors in the national flag? Okay, this is a query. Okay, so on purpose I've chosen a bit longer query. It can be small, let's say 3 to 4 words. It can be hundreds of words, and I'm going to call this encode query. So basically what I'm going to do is I'm going to use this client, which is Olama based client, and I'm using this model. So uh, to this client, I'm going to call the embed method, which returns the dictionary containing embeddings. So I'm going to pass the model name and the query, and the response I'm expecting the embeddings. So it is very straightforward. I'm using the Olama LLM stuff and getting the response because I'm calling the embed method. Okay, now let us see. So in the response, when we get the encoded query, the encoded query we will get the length, okay, and we will get the embeddings. Okay, so we'll just print the first 10 values, but we can print more number of values. Okay, so let's just run it once. Okay, so vector length is 768. Okay, so these are the numerical values, okay, or encoded values returned from by the LLM. Okay, so I've just printed the first 10 values, but I can print other values, so 768 values will be there. Okay, so this is again very simple, straightforward for the query encoder. And as I said, we need to use the same query encoder which we used for the document, the reference document. Okay, now moving on to the other part. So next demo. So here I have used, as I said, BM25 retriever. Um, so what I'm going to do is, again, it is not LLM based, it is a LangChain community based. I'm using this BM25 best match 25 retriever. So here, a very practical example is I'm going to add some data. Okay, so there is a data of, let's say, six document. Okay, or you can simply say 6 lines. Okay, this is the data, and these are the relevant part, and this is something which is off bit. Okay, just to have a different perspective. So I'm going to have these docs, and I'm going to pass on these docs to the retriever, and I'm going to say whether I'm going to raise a query. In the response, I want top three documents in return which are the best matches. Okay, well, so based on the query, whatever the best matching of these three documents, I want top three documents. Okay, I can make a top two document, top one document, and etc. Okay, so the first query I'm going to raise is, crack the interview. Okay, so if you see by looking at the data, this particular thing seems to be the very closest match to this query. Okay, closest response, because other things are not relevant to any interview or something. This is the probably the closest or the best match. Okay, and I'm going to use the retriever. Okay, and I'm going to call this restricted method to get relevant documents, and I'm going to pass query. And for now there is a need of this run manager, but as of now we can pass it as none also, right? So I'm going to print what response I got. Okay, top retrieved content. Okay, right, so let's just run it for now. So for this query, crack the interview, the first response, the topmost response is Java interview questions. Okay, and other things are also there. Okay, uh, again, if you see, so there's an interview, so there will be question and answer, and there will be uh, interpretable. Okay, so these two, this is definitely the best match, this is definitely the second best match, this will not be the correct match. Okay, but yes, so we got the response where we have, at least 2 out of 3 responses are matching. Right, now let us raise one more query which is probably more related to the entire document. So entire documents are talking about the BM25 technicalities. So I'm going to raise this query and let's see the output. So the query is, how does BM25 work for retrieval? So ranking function used, and sparse retrievers like this keyword. Okay, and this one. So if you again see, 2 out of 3 are best matches for the query. So best match and the exact response, there are two things. Best match is something which is the most closest match from the reference data. That always may not be the answer or the best answer, that is the closest match. Okay, right. Now this is again, just some data and one query is there. Now let's see from the testing or automation perspective, what better we can do. So of course, when we have this kind of query encoder implementation in production or real life implementation, then we cannot just test it for 1 or 2 queries. Okay, so we need to test it for multiple queries. So for that we need multiple data, right? So I have a data of, let's say, 100 records. Okay, so there are 500 records. So these are from different domains, so education, automotive, entertainment, and many other domains are there. Okay, healthcare, finance, right? So what I'm going to do is I'm going to cook, or have some dummy data which is lengthy 500 records. Okay, and from this data I'm going to cook some questions. So how I'm going to cook the questions? So whatever data I'm getting, okay, let's say finance. So whatever data I'm getting, so first three words will be my questions, straightforward. Okay, so if something the question is there from cyber security, then the response I should get should also be from this particular section of the data. Okay, and obviously not from the other part of the data. Okay, so that is the catch. So here the goal is to have uh, test the particular implementation for a larger number of queries and bigger data. So then we can say that, okay, this really is working, and not just working for uh, one or two queries, right? So there is this code. You can see this in detail later also. So I'm going to tokenize. Then, so let's start with this. So I'm going to have BM25 OK API. One function is there. I'm going to pass on the tokenized doc. So what is the doc? Doc is basically all the data, and tokenize. I'm going to tokenize. So I'm going to just you know filter the particular text for this new line character or any other unwanted characters, and I'm going to lowercase split the data, right? So when I run this, then we'll be able to see the proper request response. Now here, so it is straightforward, but what I've done is I've induced some error in the test data itself, that if there are 500 records, I'm going to have few records which are random, which are not relevant. So that I need to check in the response, that am I really getting the relevant response, or something which is not relevant and maybe some other purpose. So I'm going to introduce fail count. Okay, and then I'm going to insert some fixed data or some corrupted data or not relevant data for a particular section. Okay, right. So I'm going to call this get top n. I'm going to the first top n means top one response I'm going to get, and in that I'm going to compare whether it is the expected response or not. Okay, right. So first let's just run it, and then probably I'll explain much more. Right. So if you see, 278 passed, failed are 972, so 194% failure. So that is too much. Okay, so total is 1,250 documents, and again the same number of queries. So only 278 passed. Okay, so let's see couple of pass and couple of failed. So pass. So judiciary board manage. Okay, and the result is the closest top one match is judiciary board manage. Judiciary boards manage attorney client privilege. Okay, so this for this query, this is the perfect match. Okay, and for other one more example. So traffic controllers maintain low visibility approaches. So this probably is the closest match for the particular query. Okay, so there are many failures. Probably those are not exact match, or there is some noise introduced and all. Right. So the point here is that we can do automated verification also, and we can do of verification of only one query or two queries. So that is also possible. Okay. So having said that, so if you like this content, please like, share, and subscribe to my channel. Thank you.